All right, in this video, we're going to go through the solutions of the second homework sheet. So this covers 8D, which is conditional probability. So make sure you are familiar with the conditional probability formula. So basically the probability of A given B equals the probability of A and B over B. And instead of writing it as a probability like you do here, because then you're dealing with a fraction over a fraction, you can just do the number of A and B and the number of B. Okay, so we're going to do it the second way instead of using the probability. Both will give you the right answer, but you're more prone to make an error when dividing a fraction by a fraction than what you are when you're just working with one numerator and one denominator. Okay, so question 1. A card is selected from a standard deck of 52 playing cards. Find the probability that the card is a queen given that it is a red card. Okay, so we want, and it might be a good idea just to write what you want. So the probability that the card is a queen given that it is red. So queen given red. And that is probability, excuse me, of the queen and red over the probability of a red. Now, how many cards are both queen and red? There are 2. Okay, so the queen of hearts and the queen of diamonds. And how many cards are red? So that's half the deck. So 2 over 26 gives you 1 over 13. Question B, the card is a jack given that it's a diamond. So probability of jack given that it's a diamond. And here I've written probability, but maybe I should have written N. Get the same answer. Jack and diamond over the number of diamonds. So how many cards are jack and diamonds? There is only 1. And how many diamonds? There are 13. The card is black given that it is an ace. So the probability of black given that it's ace equals the number of black cards that are aces over the number of cards that are aces. So how many cards are black and an ace? There are 2. And how many aces are there? There are 4. So we have a half. Now the second one is probably the easiest one to explain, conditional probability. So let's just have a look at doing this. So we have 2 aces, 2 red aces. Okay, so the heart and the diamond, and then we have 2 black aces. Okay, so altogether we've got 4 aces. So we're only looking at the 4. So the card is black given that it's an ace. So we already know it's an ace. So this is what we have got to choose from. And 2 of those cards are black. So it's 2 out of 4, which is a half. Okay, so that's representing the conditional probability formula, or simulating the conditional probability formula. Okay, let's move on because we'll make a video short. Question 2, a number is chosen from the first 60 positive integers. So remember the word integer just means a whole number. Okay, so like 1, 2, 3, 4, not a half, 0.6, stuff like that. An integer is a whole number. Find the probability that the number is divisible by 5, given that it is divisible by 2. So we want the probability, we want divisible by 5. So we might just go divide it by 5, given that it is divisible by 2. So we want the probability that it is divisible by 5 and divisible by 2 over the probability that it is divisible, by 2. And I should have written N instead of probability, but you hopefully by now understand that we can just do the number, not the probability. Now, to understand whether it's divisible by 5 and 2, you can just say, well, we need a number that both 5 and 2 go into. So the lowest common multiple of 5 and 2 is 10. And the way you can easily find that is just multiplying them to get the two together. So 5 times 2 is 10. There is nothing else lower. So how many times does 10 go into 60? It's 6. So when you think about it, the numbers that are divisible by 5 and 2 that are in 60 are 10, 20, 30, 40, 50, and 60. Okay, so we've got 1, 2, 3, 4, 5, 6. Alternatively, instead of listing them, because sometimes that might take a while, you can just say 5 times 2 is 10. That's the lowest common multiple. How many times does 10 go into 60? 6. All right, so probability that it's divisible by 2. So we basically want to say how many 2's go into 60 is 30. And then we can simplify that to 1/5. Next one, the probability is divisible by 4, given that it's divisible by 6. So probability divisible by 4, given that it's divisible by 6. Okay, again, instead of writing probability, I should have written n there, the number. Oops, sorry, wrong symbol. Divided by 6. So remember that's the intersection symbol, and divisible by 6. All right, so as we did before, we can say 4 times 6 is 24, but obviously that's not your lowest common multiple because 4 and 6 also go into 12. So you always just got to check that. Okay, so how many times does 12 go into 60? It's 5. And how many times does 6 go into 60 is 10. So we have a half. Next one, probability. It is divisible by 10, given that it's divisible by 2. We have the number divisible by 10 and divisible by 2 over divisible by 2. So 10 times 2 is 20, but again, not the lowest common multiple. The lowest common multiple is actually 10. So how many times does 10 go into 60? It's 6. And how many times does 2 go into 60? Is 30. Okay, so we have 1/5. All right, and I might leave the last one on there. Hopefully it's the last one. Yeah. The number is divisible by 15, given that it's divisible by 5. So I'm not going to write out the notation. Let's just do it here. So 15 is your lowest common multiple. How many times does 15 go into 60? It's 4. And how many times does 5 go into 60? Is 12. So it's 1/3. Now you could actually, to check, write out the first 60 numbers. It would actually take you a very long time. And then just circle all the things that you want. But understanding your lowest common denominator is the easiest way to do it. All right, let's move on. Question 3, consider the Venn diagram displaying the number of elements belonging to events A and B. Find the probability of A. So everything in the circle of A, 10 and 5 is 15 over how many we've got in total. So that's 30. So just double check, yeah, so that's a half. Probability of A and B, so we just want the intersection, which is 5. So that's 1/6. The probability of A given B, so you can look in here and say probability of A and B is 5, and the probability of B is 20. So that gives you 1/4. So if you think about it, we want the probability that it is A, given that it's already in B. So we're looking at everything that is in B, and what's the probability that it's A is 5. So 5 over 20. And there's one more. B given A. So this time we're looking at all the A's is 15, so it's going to be out of 15, and we have 5 that are both, so 1/3. So remember, these are not the same thing, okay, and you work them out differently too. Okay, question 4. For these probability diagrams, find the probability of A given B. Okay, so this one here, we have B. What's the total of B is 5, and the probability that it is going to be A is 2, so 2/5 for that one. This one here, we need to first of all complete our table. So remember, your rows and columns should all add up. So we want the probability of A and B, which is 1, and we want it over B, so B is 5. And I think that might be it. Let's just check. Woo! Good stuff. Nearly under 10 minutes.